IBS stands for Industrialized Building System, whereby it's a construction technique which the components are manufactured or customized in a controlled environment, either off-site or in situ, then be transported, positioned, and assembled into construction works. IBS consists of two types of systems, which are closed system and open system. Closed system means all IBS components are supplied by a single manufacturer, whereby it may induce monopoly of enterprises, combined limited variety of component choices for the consumers, and relatively lower research and development improvement of the industry. Contrastingly, open system incorporates a combination of components from different manufacturers, which is highly encouraged by the CIDB. In doing so, it helps to provide wider variety of choices for the consumers and provide optimal competition between manufacturers, which will improve research and development, eventually increasing the standard and quality. This project shows an open system IBS, which utilizes precast system, steel framing system, and blockwork system. First, the site is excavated and leveled with excavators or backhoes are employed to prepare the pit for the shallow footing foundation. They receive and transmit the load directly from the columns to the ground in points. Foundation wall is erected around the perimeter, lined with damp-proof membrane to prevent moisture to seep into and weakens the foundation. Metal bearing plates and embedded anchor bolts are casted into the square concrete footing with the dimension of 600 mm by 600 mm. Extending from the foundations are concrete stumps, connected to the columns using steel base plate connection, leveled and secured with seam pads and anchoring bolts and nuts. Once mechanical connection is completed, high-strength cement grouts are applied to infill the connection voids to ensure effective load transmission.
Precast ground beams are installed, followed by cast in situ concrete floor slab, reinforced with welded wire reinforcing fabric bonds lined with damp-proof membrane. 300 mm by 300 mm precast reinforced concrete columns are vertically positioned on the floor slab, ensuring the reinforcement grout from the ground slab fit perfectly into the drawbacks. Grout is pumped in to reinforce the connection.
Once the cobbled columns are set in place, beams are hoisted to meet the cobble ends laid with bearing pads. Shim pads may be placed on ends with non-shrink mortar to correct beam soffit level if required. Beams are connected with the steel angles and metal plates, which are precasted into the cobble columns grouted with high-strength concrete. Once beams are completed, check the position and alignment of starter bars before precast wall panels are hoisted into place. Shim pads are also set on non-shrink mortar to level the ground. Make sure the walls are positioned precisely in plumb and secure it with diagonal props. Ensure the gaps and air pocket is fully grouted and watertight. On site, the in-situ molds and studs are ready for the plug-in of toilet pots. Then, the electrical and plumbing systems are connected. 900 mm width hollow core precast concrete slabs are placed on the bearing pads on the inverted T-beams and L-beams. The panels are laid according to the direction of load transmission of one-way or two-way slab to ensure effective load transmission to the beam. Steel reinforcing bars are inserted into the slab keyways to span the joint and grouted. Dowel bars are inserted to reinforce the parallel connection. All connection gaps are grouted to ensure strength integrity. Precast staircases are installed. Position shift plates at support location to correct level. 10 mm tolerance gap between precast plank and staircase is maintained. Staircases and landings are connected using tongue and groove connection, which the connection is later bolted and grouted. The staircase is then bolted down to the ground. The process repeats level after level until it reaches the top. Prefabricated steel king post truss roofs are installed once the superstructures are completed. Gusset plates and gang nails are used for connections. C-purlins are installed on the trusses using I-plate. A layer of cisolation is laid to act as heat retardant to reduce direct heat radiation to enter the interior, besides performing as water and moisture vapor barrier, followed with a layer of rock wool insulation. Lastly, the roof is finished by corrugated steel roofing sheet. This construction method greatly reduces construction time, labor, and cost. It eliminates the production of construction waste such as timber formworks and wasted materials, as all components are controlled off-site, thus keeping environmental impact minimal, besides greatly increasing the efficiency and quality control.